Here we want to draw and label the intersection of the line XY. This is our line XY and the ray RS. So we have the line XY. It is indeed a line because it has two arrows above it. We have the ray RS with just one arrow above it. And we want this line and this ray to intersect at some point R. Okay, so to begin making this drawing, we need to make a line with two points on it. So we have the line XY. So here is our line. It has arrows on the end. It's going to extend infinitely in both directions. And it's going to have 2 points on it, X and Y. It doesn't matter which one is which as long as the points are collinear and they both lie on the line XY. Now, next we're going to need to add a ray. Now the ray is going to have an endpoint R. R is always the beginning of the ray, and it's going to have another point S. The description says that the ray and the line will intersect at some point R. So R needs to be on the line XY. That's where the line and the ray are going to intersect. So this point is point R. Now it doesn't say in the description which direction that the ray RS is going in, so we can actually just make it in any direction. We'll just make it straight up in this one. It's going to have the point S on it, and it's going to extend infinitely in this direction. So here is the image of the line XY being intersected by the ray RS at point R. Notice the point R is collinear with the points X and Y, so it is indeed on this line. All right, not a whole lot to it. Let's do a few more. Let's say we want to draw the image showing all of the following information. Let's keep the letters the same. Let's say we have the line segment XY. It's indeed a line segment because it has no arrows above it. The line segment is going to be intersected by the ray RS. And we also are told that we have the plane Z. And we want the plane Z to contain the line segment XY, but not the ray RS. So it's very similar to this previous example. We're just adding some additional information in terms of a plane. Now, how do we go about doing this? Well, anytime we have a plane and some other given information, we usually want to start with a plane. It usually makes things simpler. And this makes sense because the plane either includes or it can exclude the other information, not vice versa. So the plane is usually a more simpler place to start. So let's go ahead and start by drawing our plane Z. So here is our plane Z. There's our plane, and we always want to label our planes. We actually want to label all of our information. So here's our plane Z. And we want to show that the line segment XY is included in this plane Z. So let's go ahead and draw our line segment. Here's our line segment XY. We put endpoints on the ends because it does indeed end. Here's X and here's Y. Again, it doesn't matter which one is which. So here's our line segment XY, and indeed lies in the plane Z. Now we want to show that the ray RS, just like above, is going to intersect the line segment XY, but it's not going to be contained in the plane Z. So it's actually going to be very similar to this one. We want to show that it indeed intersects at some point R, and since the ray is not included in the plane, we want to show that it is going to come up out of the plane. Now, if you imagine the plane, imagine this plane Z as the floor. The ray is going to come straight up out of the plane, so it's not going to be included in the plane. The point R is actually included in the plane because it is collinear with 2 points that are actually lying in the plane, the point X and Y, point Y. So R is in the plane, but the ray RS is not included in the plane, so it's actually coming out of it. All right, so this is actually where we begin to see things in 3 dimensions. We need to see this coming straight up out of the plane, and we can do that by imagining that this plane Z is something like a floor or a piece of paper or some flat surface. So very important. Let's do a few more. Let's say we're given a line. Let's say we're given a line Z has arrows on both ends because it extends infinitely in both directions. And this line contains 3 points. It contains the points A, B, and C. And we want to name this line in 3 different ways. All right, so actually we're learning that lines can be named in several infinitely different many ways because there's an infinite number of points on this line. Here we're just identifying 3 of them, and we want to name it in this line in a few different ways. Well, an easy one, just a spot, is Z. This is called line Z. But we can also name it in a few different ways using these points. We can also name this line AB. And we can do that because AB are collinear. They both points lie on this line, so we can think of this line as A and B, extending in both directions. Another thing, we can use B and C. We can call this line BC because the points B and C are collinear and they both lie on this line, extending in both directions. So these are 3 different ways that we can actually name this same line. All right, so very cool, also very important. Let's take a look at the next one. We want to know what type of geometric object is the intersection of a line, a line and a plane. So what geometric object describes the intersection of a line and a plane? We want to draw this answer. All right, so let's go ahead and we have plane in this given information, so let's go ahead and start by drawing our plane. So here is some unknown plane, and we're going to have a line intersecting this plane. So imagine that we have a line going straight through this plane and coming out the other side. So here's our line, has arrows on both ends, and we know a line is going to have at least 2 points. So here's a point, and here's another point. Okay, so here's our line passing through this plane, and we want to know what geometric object is the intersection of this line and this plane. You can see right here that a line intersects the plane at a particular point. So the intersection of a line and a plane is one unique point, and that's right here. All right, let's do another one. Let's say we want to know what type of geometric object is made by the intersection of, let's say, 2 planes. So let's say we have 2 planes. Here is our first plane, and we have another plane intersecting this plane. Here is our second plane. Imagine this plane is going straight through the first plane. Okay, we want to know what geometric object is denotes the intersection of these 2 planes. Well, you can see that when 2 planes intersect, they intersect at an infinite number of points here, and we know this to be a line. So this line right here is the intersection of these 2 planes. Every point on this line consists of every point, an infinite number of points, where these 2 planes intersect. So the intersection of 2 planes is indeed a line. All right, let's look at one more. Let's say we have 3 non-collinear points. We want to know what type of geometric object is made by 3 non-collinear points. We want to draw this. Well, we know by definition that 3 non-collinear points represents a plane. So let's go ahead and draw a plane and show you why this is correct. Excuse me. Okay, so here is a plane, and we want to show that a geometric object consisting of 3 non-collinear points is a plane. So here we have a plane, and we need to draw 3 points that are not collinear. Notice that these 3 points are non-collinear because we can't draw one single straight line that will connect all 3 of these points. So we have the points A, B, and C are non-collinear, giving us the plane Z. Just to name these. So very important to know that 3 noncollinear points are actually, that's what it takes to draw a unique plane. All right, so look over this video again. This is actually very basic information in terms of lines, segments, rays, and planes. And we need to know that points are very important. And these points and lines, they actually don't represent any space, but they only represent a particular area or a particular point. All right, so look over this a few times. This is a very basics of geometry, and I'll see you in the next video.